Okay, this is how we approach question 4 on page 413. This is the question where it says that two identical boxes of mass 10 kilos are connected by a light inextensible cable. Okay, so there's the two boxes of 10 connected by the cable. One is pushed away from the other. Well, if one of them is pushed away from the other, let's say we're going to push this one here, as we push it, both of them will move. That means we can actually consider it, if these connected particles, as one big object, okay? Now we know that it's pushed with a force of 75 newtons. So we've got the thrust going that way, pulling it along, that tension, pulling it along, whatever we want to call it, thrust or tension in this case, it's being pushed along. There's thrust actually because it's applied to this box. Okay, and so 75 move in there. Now we know that the friction is acting backwards. All we're going to do on this one, I have also considered the fact that overall there is a mass of 20 kilograms from the two boxes and there is no acceleration. So what we're going to need to do is we're just going to need to do a basically forces thing. It's going in this direction, so I know that the thrust, take away the force, is going to be mass times acceleration. That take away that is mass times acceleration, the net force. Okay, now I know that T is 75, F is something I don't know, the mass is 20, and the acceleration is 0. So that means that 75 minus F equals 0. So obviously F is 75 newtons. So there's a friction of 75 newtons. But that friction is being caused by the two identical boxes. Therefore, as they are identical boxes, we can do 75 divided by 2, and each one, okay, has a friction applied to it of 37.5 newtons. Hope that's okay.